but you can use it for anything, literally anything. And then I'm going to look at the user journey to help people to understand the importance of separating the user from the stakeholder. Although you can include the user in the stakeholder, you have to be aware of the importance of separating the two. That's why I prefer to consider the stakeholder to be separate to the user, or the end user, or the operator, whatever you want to call the person.
That's an interesting point. So, and you will do all within the lecture, or you will have to assign something?
No, we'll do everything within the lecture. Everything
Great.
is in the lecture. No, don't worry.
I don't worry. I'm more solid than Gibraltar rock.
And by the way, Professor, if you would like me, okay, we've got the COVID crisis, so I can't actually move easily. But if you would like me to come to the university and do a testimonial or a guest speech for whatever topic, not just about systems engineering, because I also do other things, just say so.
Sure, that sounds very interesting. Currently, our lecturers still strongly recommend. Let me say, theoretically, it's mandatory to carry it out all remotely. But for instance, in the last months, we have some blended lecture, and hopefully will be possible again soon. So in case, I will be very delighted to have you in Genoa and to have opportunity to have interaction, even if the situation will improve just a little bit, that could make possible to have combined live and virtual lectures. That could be good, obviously. I strongly in favor of web technology for lecture nowadays due to the reduction of the risk, but it's evident that live interaction are more effective.
Absolutely. In fact, I'm working with a potential customer, and the idea is to, how can I best explain this? Let's say one thing is virtual learning, another thing is face-to-face learning, and we know the differences. Or let's say we understand the repercussions if we favor one method with respect to another one. But what is not understood is what are going to be the long-term repercussions if we decide to do much more virtual learning. And that's going to be it's going to be a discontinuity in lecturing and teaching in general and training. So in my opinion, and that's why I'm working with this potential customer, we're looking at revisiting all the previous research on learning. So it's a bit like lifelong learning mixed with digital technology. But it's not the classical translator, I don't know, an exercise into a slide deck. This is not the concept. The concept is to really look at the core things that make the difference between when you do face-to-face training with respect to when you do it online. And there are big differences.
Sure. I think that this COVID is stressing this aspect to learn to do it better, because it's something that we was doing since long term, but completely different percentage. And
yeah, I also think as well that we are now assessing much better all nothing really has substantially changed. What has changed is our assessment of the good and the bad things of face-to-face learning with respect to virtual learning. And I think here is the biggest challenge. For example, how do you simulate? That's assuming that it's the best way to do it. How do you simulate laboratory work at a distance? For example, it's for example, I've got a couple of exercises where the benefit of the actual training, in particular the exercises, is when you work together in the same space. And it can't be a virtual space. It's got to be a real space. And this is what we're struggling with right now. How do we do something that is essentially you learn by doing, but learning by doing means that you have to be physically in the same place as the other people. I think the virtual learning is it's ballast. It's heavy weight for certain things, and
Yeah.
I think we have a lot of the journey. We've just started this journey, and also the tools. I mean, the digital tools that we have are simply not up to the challenges that we have.
Based just on this year experience, probably it could be easily improved drastically, because most of the constraints are not too much related to technology, but to structure and process. Mm-hmm. By the way, I feel you have even the opposite aspect, that we stress the training and education under COVID-19, but even regular work has been overstressed by it. I mean, even in this case, a virtual meeting was going since decades. But now it's different. And I feel that even in this case, we have to think about how to reorganize teaching, even to teach people to do some work that previously was done mostly live, to be carried out in large percentage, even remotely, or in more efficient way, even remotely, because I feel that after this experience, a lot of people will try to keep the current direction in many sectors, not as a constraint, but as a choice to save time for traveling, to save money for traveling and infrastructure. So for sure, I mean, the people is still working in office even during the most critical periods, or on the construction yard, or on the factories, etc. But obviously, it probably it's possible to increase the percentage, and especially the quality of what we do, with better tool, but even with better organization, procedure, forma mentis, and obviously training education is crucial.
Mm-hmm. Oh yes, certainly the status quo has been broken now. I don't think we will go back to 100% working in the office. Ciao Alfredo. It's going to be probably, I'm not sure of the percentages, but it's probably going to be at least 50-50. But that opens up a whole series of issues. You know, if you work virtually, for example, let's suppose you've got a company car. Well, if you work virtually, you don't need the company car. So now that company car might have been used at the weekend. So all of a sudden you haven't got a company car.
And this is one of the issues now, because this is a clear benefit that will go out.
Absolutely. And companies will save money.
But I feel company will look even to save in other ways. I may be, let me say, pessimistic, if you like, or optimistic, but I feel that company will start to say, okay, if you work from home, it's not just your lunch ticket, that it seems nothing, but for many employees, it's quite a while. It's not just office space. It's obviously not just the car, but could be even that maybe we give more flexibility, and we maybe reduce sometime in the salary. There are some, let me say, additional recognition that could be mitigated, etc. Especially for employee. I mean, executive was already spending 2-3 days in, let's say at least 2 days in smart work even before the crisis. Most of them, let's say.
Yeah.
But
it's going to impact many things. We don't realize, I think, of the impact. You mentioned that thing about work. Apart from the teaching and the lecturing, etc., what happens? What has happened with the normal day-to-day work? I can see dramatic changes already occurring. Really big changes. But it's been sort of like it's almost becoming the norm to work 12, 13, 14 hours a day. And that can't be sustained. So
that's a good point. That's a good point. I feel it will be very interesting because, you know, we crossed, I feel I'm too young, but I just read currently a book that dates back 150 years that was addressing the workers and pointing out almost all the problems that we have nowadays with work.
Yeah.
But at that time, the limitation on the time for working was a major issue, not yet achieved, because in the 80-50, the people was working 12 hours, mostly regularly, and I feel was not yet the Saturday off. So we arrived in a world where Saturday seems totally natural to have 2 days per week free. No, that is something that some part of the world is not at all recognized. This is some kind of strange twirling the system, because from some point of view, exactly, we increase the number of time, especially the availability, and it could not be sustainable on long term. But what will happen? We have even automation that will push to reduce time. Will be interesting what will happen, because it's not really clear at the moment what we can do. What we have a middle class that will work more from home. We'll have.
I can say actually what I've witnessed anyway. For example, I work or I'm in contact with the Politecnico di Milano.
Yeah.
And what I've seen since the COVID crisis, before I could call and we could organize a meeting in the space of a couple of days at the very, very most, or I could call maybe at 6:30 in the evening and I would always get an answer. Now, the answer, if I get it, it's after about 3 or 4 days. Why? Because there's so many department meetings of some sort or the other, and it becomes virtually impossible to get in contact with the people, because they work until maybe 8 o'clock in the evening. And I don't think this can be maintained or sustained for a long period, because people are already saying, I don't want this life anymore. I want something else.
It could be interesting, especially when it will be not mandatory, but it will be a decision, no? Because with COVID is easy, but in the future, what people will decide.
Yeah.
Any case, so we passed the academic quarter, as Alfredo Garro last time introduced. Alfredo, welcome. David was
yes,
hello.
Thank you, Agostino, and welcome to. Good afternoon to everyone. And I think it's a very interesting discussion, and maybe we should discuss about future kind of work organization. And as you noted, they are very strange behavior, maybe emerging behavior that, as I told you during the first lesson, they could be opportunities and not threats. Okay, so very interesting discussion. However, we are here now for starting the week with lesson number 3 on systems engineering, and our speaker today will be David Ward. It's our vice president in ICE in SOSE Italia, and now currently David is with TMC Italia. So it's a consulting company. And today, David will talk about systems engineering processes and standards. So maybe it's a more technical lesson respect to the lesson number 2 on system thinking and risk assessment and management. And I really hope that David will provide you an overview on processes with, as you know, with people, and are in main topic in systems engineering. So we have to think about product, but also about processes and people. And processes are very important for organizing the way in which we apply the systematic and systemic approach. And as David told us, systemic is not, in some cases, is the opposite of systematic. So processes from a systems engineering point of view are very important. And standards, because we want to apply systems engineering in industry, and the standards are very important, both from the methodological point of view, so the way in which we apply systems engineering is guided and driven by standards, but also concerning processes and products. So there are international standards that we should know and follow in our practice, not only for qualifying our products and services, but also for better sharing knowledge with other people, companies, and working teams, and also for adopting very well-known and proven processes and techniques. So I don't want to steal other time to David, and I hope that you will enjoy this lesson. And David, I will leave you the stage, and thank you so much for attending this new lesson on systems engineering. Thank you.
Okay, thank you. Can everybody see my screen? So we're going to speak about systems engineering processes, and in particular, I will be emphasizing the technical processes, because these are the ones that are more usually more cited and also more interesting from the engineering development perspective. So we'll see the systems engineering processes essentially in this context, but I will make reference to the other three categories of process, which I actually also mentioned in the previous lesson. And then we'll finish off with some discussion on standards, and in particular systems engineering standards. Now, the timing, we're about 20 minutes behind schedule, so you need to add about 20 minutes to this timing that you see in the slide here. So we'll have a break roughly in about 50 minutes time, so it should be around about 10 minutes past 4 when we have our little break. So you heard something mentioned by Alfredo when we were speaking about processes and people, etc. And this is these two factors are part of the 3P law for systems engineering. The other P would be project, of course. Sometimes it's also translated into product, although I prefer project for the simple reason that it's not just about products, it could be also about services, or products and services. So that's why I usually leverage project, process, and people in this discussion on the 3P law. We'll also look at we'll go back to the 15288 standard, the NCOSE handbook. And as I've just said, we will focus on technical processes today, but the other three categories, technical management, acquisition and organization, project enabling processes, will also be mentioned again. We'll also see some connections to the V model and have some fun with what is called the IPO diagram that you might have seen in various formats, but that will be one of the exercises. So let me just move on and speak about, again, the 3P law. Now, the 3P law, it actually dates back to another standard, a very famous standard, which was the 632 standard. And this is an image that's coming from a presentation that was highly recommended at the time in 1994, so the mid-90s essentially. So that's more or less 25 years ago, essentially. So what we're seeing here is, again, that emphasis on the 3P law, but this is not new. It's not something that I've invented or anybody else has invented recently. It's going back at least 20 plus years. You can also find actually some other interesting elements of this discussion by the gentleman that you see in this picture on the right-hand side here. He's from Northup. And a Grumman as well, and the reference is this one here at the left hand on the left hand side of the slide. Now, the key thing that we're going to see today is process. But as I said in the previous lesson and just announced here, processes are there to help you develop the product or the project more effectively, or maybe also the service. But nevertheless, processes rely on people. So we can't forget the people part of our process. But here we'll focus really on process, particularly the technical type of process. Now, what is a process? So, in your opinion, is what you see in this slide correct, or do you have a different opinion when it comes to defining a process? Here it's actually described in two ways, as a noun and as a verb. So I ask the floor, the people that are listening, if they have a different way, or did they have a different opinion on the definition of process. This is very important in systems engineering because a lot of the key processes in systems engineering are interlinked, just like we see in the definition of a system, where we have interconnected elements or parts or components, assemblies and sub-assemblies and so on. So a process is, the definition is fairly important because it's going to impact how these processes are linked together, particularly the technical processes. So I ask again, does somebody want to give me their definition of a process, or just simply say, yes, David, I agree with what you put in this slide here? Are there any comments, in other words? So please come forward because we need interaction today to make the afternoon worthwhile.
I would say, maybe using some terminology from informatics, that a process is a collection of tasks that leads you to an end, to a stated goal, and these tasks may be simple or complex. And by the way, I would say that in the scope of a process might be included smaller processes that for our process we are interested only in their end state, but actually are quite complex and maybe long inside.
So what you've just said is more or less in line with the noun definition of a process. So a series of actions or tasks, if you prefer, that you take in order to achieve a result. So there are two key things already in this noun version and also in what you've just said. The outcome, the result, the output or the outputs, and also the tasks, the actions, the activities, and maybe other processes, because remember that a process can actually be a collection of tasks that nevertheless are coming through maybe other processes. So there can be a circumstance where a process can actually be part of another process and so on. So essentially, a process is what we see defined here, and it's defined in terms of a noun and a verb. So a series of actions that you take in order to achieve a result. And there's the example there. She arrived at the correct answer by a process of elimination. The verb to deal with something, meaning visa applications take 24 days to process. So at the core of this is probably this thing about actions, tasks. But nevertheless, we need something beforehand, and that will be certainly clarified when we come to the IPO diagram. So we need something before we start the activities. We need to have a good idea of what is needed at the end of these activities, so the outcomes. And we also need other things as well, meaning something that helps us to either do these activities or complete these tasks, and maybe also control them. So these are another two elements as well of this discussion. Now, there's a very interesting video that we're not going to see, but I've actually provided everybody with this video. So if you were to click on that picture, you'll be able to see the video. And this particular gentleman is speaking about the technical processes, and in particular, the technical processes tied to the system life cycle. And the interesting thing about the video is that not only does he speak about the technical processes, but he connects them to this standard, the ISO 15288 standard, which is the reference standards for the life cycle of the system, but also the life cycle of software. So if we have a system with software, this standard is applicable both to the system as well as its software. Now, if it's just software, so if I'm, for example, developing a web application, this standard is also applicable to the software by itself. So this is a fairly important comment that I'm making now up front, because we will see its importance better when I come to the discussion on standards. So the 15288 standard is actually a standard that covers both systems with or without software, and also with software or software on its own. That's something that you need to bear in mind. Now, we looked at three different ways of systems engineering, or three different views of systems engineering. And lo and behold, today, we're going to speak about the process perspective of systems engineering. So what does this mean? It means that when we speak about systems engineering, we can see it as a perspective, we can see it as a profession. So if you want to be called or certified a system engineer, and you're going to do it through INCOSE, for example, you're going to have to go through a specific set of tasks in the terms of exams, for example, but also in terms of work experience. So essentially, not just learning something to get through an exam, but also to use that knowledge that you gain, for example, at university, within the domain of your profession of systems engineering. But there's this second aspect, systems engineering as a process. So this means that when we speak about systems engineering, we have to speak about process. We can't distinguish between the two. Now, I mentioned in one of my previous slides this idea of going from user and stakeholder needs all the way over to the definition of system architecture. So that there was an arrow, this one here, that was showing you different steps or stages or phases in which the project actually goes through, and usually the vast majority of this work is done with the system engineer as being the lead engineer to derive the system architecture. And then afterwards, there are other things that we will see in a while. So this arrow here is actually indicating a series of steps, stages, or phases to get to this point where we've defined the system architecture. And this is in itself, it's a process. Actually, it's a collection of processes that we'll see in a while again. And obviously, once we have terminated the system architecture, we can either go forward as a system engineer and develop some of its detail and go on all the way over to the moment that we actually retire the system. After that, or maybe even earlier, if we've finished our system architecture and they don't need us anymore, as a system engineer, we will go through a cycle. And typically the cycle involves looking at technologies, changes in regulatory trends, market requirements, market needs, and obviously the redefinition of the user and the stakeholder and obviously their needs. So this picture that we see here is actually a clear indication that there's a process, at least one process going behind all what we see on the slide when it comes to determining system architecture. Actually, formally, there are at least 3 other processes actually happening along this path here, at least 3, if not more. So now I'm going to ask you a question. When it comes to justifying processes, what does this mean? You see some cues here. So I've literally left finding commonalities, combining different needs, and finding simpler ways. And as we'll see in a while, there are some pictures to help us understand what these 3 things actually mean. There are actually more than 3 things, but these are the 3 key things that I've found in justifying processes. So in your opinion, what would be a process for finding commonalities? How would you find commonalities in developing a system?
Might be scontato, might be just start with a simple comparison first.
Yeah, that's a good example. That is a very good example. So If we have, for example, the electronics engineer, the mechanical engineer, the software engineer, I don't know, the industrial design engineer, and so on, working together on the same product or same project or same software, embedded type of product, then it's obvious that they're going to have to work together to find something that connects them together. There will be commonalities. For example, in the mechanical engineer would need to know the size of the printed circuit board. The software engineer would need to know the size of the memory in the microprocessor that the electronics engineer has chosen. The industrial designer or the industrial design engineer needs to know the maximum size, for example, of the product, and maybe other things like human factors or usability aspects, etc. So we need to find commonalities, and it's that meaning that we need to have a common goal, and obviously the common goal is to make a successful system. You heard from me in the first lesson or in the last lesson that we need to solve a business problem. That's essentially, why systems engineering exists, and particularly when the system is complex and it has emergent features. What about this thing about combining different needs? Why do you think there could be an example or a need for a process or a collection of processes to combine different needs? Any offers? Roberto?
Maybe trying to abstract, to use an abstract idea of the needs so that they can be more easily managed. Yeah.
Well, we could have different stakeholders. We could have, I don't know, the manufacturing facility, or maybe the manager of the manufacturing facility that has specific needs. You could have somebody from the commercial department that needs to launch the product, or maybe needs to have, I don't know, a specific cost, or maybe somebody in sales needs to understand the selling price and so on. Obviously, when it comes to finding simpler ways, we know that the simpler system is usually also the most reliable. It's probably also the one that is most cost effective as well. So these three things here are closely tied to systems engineering processes. As an example, therefore, from a graphical perspective, typically what we're trying to find are collecting common factors and in some way factoring to determine some combination. So we come out with a common understanding of what is needed. We need to have a fixed idea of what the product content, in particular the system architecture at the beginning, is needed to deliver what the customer or the end user is expecting from us. From a combining different needs perspective, at the end of the day, if we never manage to work together and find a common solution that satisfies everybody, bearing in mind that each one of us has different needs within the project team, then we're not going to be successful. We know that it takes longer, it's more expensive when we can't come to a common agreement and a consensus on, for example, certain design features and so on. And this is part of the initial part of our, let's say, life cycle journey. And then obviously finding simpler ways. And we know that as complexity increases, we need to be able to assess the circumstances that we have at the beginning and clarifying by simplifying for example, the system needs and the requirements before we actually move forward and we design something. Now, from again, from a systems engineering process perspective, we know that the systemic way of doing things is to work from the top downwards. So we need to have some form of top-down synthesis. And generally, once we've defined the needs, we'll end up with some high-level system requirements. And then after that, the subsystem requirements, the requirements of things like components, parts, and so on. So this is a fairly important graphic here, even though it might not appear to be an important graphic, because it's actually captured this importance in this diagram that you see on the right-hand side. Without this feedback mechanism that I've actually added, this is what is called the IPO diagram. So the input, process, and outputs diagram. It's called an IPO diagram. Now, in the case of INCOSE, so here we're speaking about the systems engineering way of looking at the IPO diagram. They've added another two things. They've added controls and they've added enablers. Now, controls are the things that we would need to have in place, such as quality control, project charters, quality assurance, and things like this. The enablers are the things that we need in order for us to be enabled to do the things that we have in this central box, which in this particular case is indicated as activities. I can replace activities with tasks. I can replace them actually with processes as well. So the concept is to go from inputs to outputs. Now you can imagine that if I haven't got enough inputs, irrespective of the clarification of the activities and the controls in the enablers, what is probably going to suffer is either the number of outputs and or the quality of the outputs. Another thing that's interesting, this is why I've added this particular flowback here, this feedback mechanism. We need to have something that tells us that what we have here is respectful also of what was expected at the beginning. So we need to have a feedback mechanism. Not just that though, although you can't see it here in this particular IPO, there will be a collection of other IPOs either ongoing simultaneously. So imagine a collection of these diagrams, one on top of another, or they will be in succession afterwards. So moving to the right here. Was that clear for everybody? Is that clear?
Yes.
Yes.
Now, when it comes to the technical processes, here you can see in this left-hand box, there are, in terms of the Systems Engineering Handbook, and obviously in INCOSE, and also the 15288 standard, because the 15288 standard mimics what is in the actual handbook and vice versa. You see that these 14 processes are classified as technical processes. The walkthrough, the logic is to go from business or mission analysis process, where we would define the business model or the business case, sorry, rather the business case. Business model would include other things as we'll see later on. But nevertheless, the business or the mission analysis process is where we define our business goals, our business requirements, where we have an idea of on what basis will we, does our project, does our system depend in order for it to be successful. So it could be, I don't know, the volumes, the selling price, the cost of goods. It could be anything that is captured in this idea of the business case. And then we move into the stakeholder analysis, the system analysis, the architecture, design definition, and so on. So the actual walkthrough is from this box downwards, and then from implementation backward to integration, and then the actual life cycle of the system ends with the disposal process. So these 14 technical processes are the backbone, let's say the map to develop a successful system. Now, as you saw in that previous diagram where we were looking at system architecture, I actually mentioned to go from the user needs and the stakeholder needs to defining the system architecture, we needed to do other things along that path, along that arrow that we saw previously. And exactly if we see it from the technical process perspective, the three things that we need to do before we start off with the system architecture is clarify the business process, clarify the stakeholder process, and clarify the requirements process for the system. before we can actually start the architecture. Now, because of the complexity in systems, many companies are now starting to do these first 4 processes actually almost simultaneously, to reduce time, to reduce investments, and so on. Actually, there are actually companies that are also anticipating some of the other processes as well. And this is to accelerate the development of the product or the software, or in general the system. And then we have the other 3 categories, so the technical management processes, the agreement processes, and the organizational project enabling processes. And these 2 can be started off also during that walkthrough where we had the arrow all the way up to the system architecture. So for example, if we are starting off with stakeholder needs, we might need to involve maybe procurement, somebody that is in, for example, the supply chain work that is done within their company, and maybe contact suppliers. So it means that probably in these first 2 to 3 processes, we're going to initiate something also in the agreement processes, as well as doing other things such as knowledge management, assessing risk, thinking about configuration management, etc. So there are quite a few processes that we need to either instigate or start to begin with when we develop a new system or we modify an existing one. So how are these 4 categories of process linked together? Actually linked together in this diagram here, and this is coming from another standard, the 24748 standard. It's actually in the -2 version of this standard, which means that it's a chapter essentially. That dash means essentially a chapter, or maybe a specific version of a standard that is linked to the 24748-1 standard. And essentially what it states is this: we start off with the definition of the marketplace need. This is crucial. If we get this wrong, everything else that it happens between this moment to the actual delivery of the system to the marketplace will be affected. It will be affected in terms of cost, schedule, risk, reliability, robustness, applicability, usability, human factors, and so on. So we need to understand what the marketplace is requiring of us, because otherwise what happens afterwards is just a consequence. Now, when we start off with the definition of the business analysis, therefore the business case of our system, and we're looking at that first process that we saw before in the 14 technical processes, what we're looking at is what is called the CONOPS. The CONOPS is essentially an abbreviation of concept of operations. It's the element that we will see in a while that is crucial to define our system, particularly from a business perspective. There can be technical detail, but more often than not, the CONOPS, or the concept of operations, is something high level. Nevertheless, it's the essence of the system, particularly from the business and stakeholder perspectives. So, how are these technical processes connected? They're connected, as you see here in this diagram here. So as we've just seen, we would start off with the business analysis, and we would end up with the disposal process. Now, there could be circumstances in the company where you're working that you don't do all of these processes. For example, if you are a company like TMC, like where I work, or maybe in another company that provides services, consultancy services, or just does something specific within the development of the system, you can have this this schematic here drastically reduced to maybe just two or three processes. Typically, though, when it comes to systems engineering, the first 4 processes are the key things that are needed anywhere. So you'll find that irrespective of the circumstance, meaning the company where you work, you will certainly see the first 3, if not 4, processes, as you see indicated here. I worked in a company where our sign-off was actually when we were validating the system. Actually, the validation was left in the hands of the customer of the company where I was working. So essentially, my previous company was focusing on the first 10 processes. There are companies that deliberately work just in the disposal phase, such as in recycling plant, for argument's sake. You can also see underneath that I've reported the 15288 life cycle process. This is the generic one, and it starts off with the concept stage. Now, if I want to complete this, then what I would need to do is to add a schematic like this, meaning that, and we will see this in one of the exercises that we'll do afterwards, what I would have here that I'm indicating on the left-hand side is maybe some form of scoping of the business case. So if you like, the concept stage is more or less from this moment, the stakeholder needs and requirements definition moment onwards. So this area here is usually where you assess the business case. So for example, you might, if you're working for a company that develops components for argument's sake, or develops solutions for specific technical problems, then the customer might say, can you give me a project proposal for this type of work, for this type of unit, for this type of component, etc. And you will come up with a business proposal, and that more often than not is seen from your perspective as being the analysis of the business case, and you put together maybe a project proposal or even a project charter. And this would happen in a process that is typically attached and is before the concept stage. And it's usually called the business opportunity stage or something similar. So the first 4 technical processes, as we see here, are the ones tied to business or mission analysis, stakeholder needs and requirements definition, system requirements definition, and architecture definition. So you can see here that what I've done is I've taken that graph or that figure where we had the 4 categories of process that was starting off with that yellow box where we had the definition of the market needs, and I mentioned ConOps. So this is the area here where we are defining the concept of operations. If, as I say, if we get this wrong, then anything that happens afterwards it's a consequence. So you can't actually make big changes and big improvements if you get the business case wrong. The business case, therefore, is part of systems engineering, even though you might not be aware of this. And you can see that there are 3 key moments. Actually, these are documents. One is called the BRS, which is otherwise known as the Business Requirement Specification. And this is coming from here, this box here, so the business analysis. Then we get into the operation environment of the business or the enterprise, and we end up with something that's called the STRS, which means the Stakeholder Requirement Specification, which is a product of this second process that I'm indicating here. And then we move into this, what I call the swimming pool. And you can see here that we're oscillating between the system requirements process and the subsystem requirements process. And generally, the outcome of this work is what's called an SRS or an SYRS, which simply means either software requirement specification or system requirement specification. And this would be the product of this process here that I'm indicating, so the system requirements definition. And then obviously, as we start our work with all of the disciplines involved in the project, we will start to look at the architecture and therefore define the architecture. Now, the interesting thing here is that what I call the swimming pool is actually the operations concept area, meaning that the swimming pool is where the engineers love to hang out. This is where the engineers dive into the swimming pool, even if they haven't clarified the stakeholder requirement or the business requirement, and start to develop something. And usually one of the things that goes wrong here is that the engineers, particularly of the other disciplines, so the mechanical engineers, electronics engineers, software, firmware engineers, etc., are the ones that will focus on their specific discipline and neglect the entire, if not just part of the actual system that needs to be delivered. So This is called the swimming pool by me for the simple reason that I imagine this to be like a swimming pool where you have the kids around the swimming pool for a swimming lesson, and the swimming instructor says to the kids, do not go in the swimming pool until I say so. And then the instructor sort of like turns around and already one of the kids is in the swimming pool. Typically, this happens also in projects because the engineers want to start their work as soon as possible. But you need to understand the system before you actually can focus on your specific discipline needs. And the system engineer has to check this, meaning that the system engineer has the accountability to make sure that the disciplines don't start until everything is being clarified beforehand, meaning the business requirement specification, the stakeholder requirement specification as a minimum, if not defining also the con-ops and the ops-con, and maybe also the beginning of the system requirement specification, high-level system requirement specification. What does this mean translated? It means that there's a journey of this type. So what you've just seen is specified as a journey, starting off with the market needs, just as we saw for those 4 categories of process. So I believed I asked you this question in one of in the previous lesson, and somebody actually got it very closely to the point, meaning that they actually were able to understand that this was a system, a medical device in this particular case, to monitor something of the baby that you see here indicated on the left-hand side, that was then picked up as a signal of some sort, captured in a data format that was then transferred to a mobile device that was then connected to a cloud service. And this was a device that was monitoring the body temperature of a baby. And you also saw this operations concept translated with more detail. Now there are the following steps after this become really, really complex. So imagine this picture that you see on the right hand side here being the first layer. If we were to do exactly the same type of diagram for each one of the disciplines that we saw previously, you can see a lot more detail, actually a tremendous amount of detail, even though essentially this is a system, as we see on the left-hand side here, that serves the purpose of monitoring the body temperature of the baby and nothing else. So you'd say this is a fairly simple system. It's actually very, very complex, particularly because of its extensiveness in terms of system. So when we think about this walkthrough, and this walkthrough is actually coming from also the 29148 standard, which is about system requirements, you can see that the BRS, the STRS, and the SYRS or the SRS are interlinked. So we can't dive in, as we saw previously in the swimming pool, without understanding what's happening at the stakeholder level and obviously at a business level. Is that clear for everybody? Clear?
Yes. Yes.
Yes. Okay. Let me move forward. Now, when we speak about architectures, and we're speaking about system architectures, remember that the definition of a system is very, very broad. Nevertheless, it's a question of seeing the whole, which means a question of seeing a collection of elements that are interconnected and that interact in somewhere. That would be more or less the definition of our system. When it comes to looking at the architecture, what we're looking at is what we've seen in those 2 previous pictures. So something that depicts them in a certain way that helps us to understand the interconnections between the elements. You also saw in the previous lesson that I mentioned that thing about the complicatedness of a watch mechanism, and you saw the differences between a pendulum clock and a wristwatch in terms of blocks. When we come to the point where we're defining the blocks and how the blocks are interacting, we are actually defining the architecture. Whether this be a software architecture, hardware architecture, it doesn't make any difference. A key thing, though, when it comes to looking at con-ops and ops-cons, is to realize that we can use systems engineering for architectures in general. So, for example, in ConOps architectures, we can speak about societal architectures. The architecture, for example, of a new industrial district, or maybe a new city. You know, I'm sure you've all seen the enormous progress that China has made over the last 20 years. There you're looking at societal type of architectures. You can also look at it from the enterprise perspective, so the company perspective, as well as its departments, therefore its organizations. Now, the key thing here is that here we're speaking always of environments, but these are a much higher level and a much broader level and a much probably deeper and human related level when it comes to looking at ConOps architectures. If we look at it from an ops-con perspective, here we're looking at systems of systems architectures, so big infrastructure. So if we think about transport, we can't just think about the metro. We can't think about the underground. We can't think about the underground and the metro or whatever it is, or surface rail by itself, because we know that that particular system is connected to another system. For example, the bus system, the tram system, and so on. So all of these architectures that interact together can be represented as infrastructure, and therefore be classified as a system of systems. But I can also go to the next level downwards and think about system architectures, just as we've been discussing for product or software development, and then go further down and move to subsystem level, and so on. So that too is also an idea of some form of environment, but this becomes much more specific. We're looking at much higher and better and greater detail, I think, when it comes to this type of architecture. And as we saw for the monitoring of the body temperature for the baby, as we move along our development timeline, we will get more and more detail. And the more detail we need, the more things like needs need to be clarified, requirements, and so on. Interestingly, when it comes to looking at architectures, there's a very good standard. It's a double standard. It's an ISO IEC standard, which is the 42010 standard, and that is specifically dedicated to the definition of system architecture. If we'd had more time, or there would have been the opportunity to have another module, I would have done system architecture and looked at that standard together with you. So if you have the opportunity, then I suggest that you look at that standard, and I'll show you when we come to the standard session how to do so. Now, we know that there's a combination of the project management and the engineering management factions in any system, particularly engineered system or man-made system. And we also know that when we start off with a project, the risk is high, and our hope is to reduce that risk as we go along this journey. Now, there are several moments along this journey where we have to make crucial decisions, such as the definition of the system architecture, the definition of, test procedures, validation, and so on. So this journey here and these steps that you see indicated here are all there to make sure that we reduce the risk of system failure as much as possible. And that is managed both by the project management people and the engineering management people, in which, for example, in engineering management, we also have systems engineering. Now, some people now call the engineering management blue box that you see on the right-hand side actually systems engineering. Why? Because the actual engineering management is in the hands of the system engineer now for a particularly complex project. But nevertheless, you'll probably find in some companies the concept of including in engineering management also systems management. So I mentioned that thing about the business space versus the business opportunity and the connection to the 15288 standard. So when we are looking at the initial part of our project, and we're at the top here, what we're looking at is understanding who the client is, who is going to buy the product, who is going to use the product, the end user, what are the declared and latent needs, what is needed today as well as tomorrow. So this journey starts off essentially with the definition of the business space versus the opportunity, meaning that here we define whether we should go forward with the business proposal before we actually start to develop a solution, if not more than one solution in the concept phase or stage. One last thing, when it comes to systems engineering, what is the minimum expectation of the system engineer? Typically from the project manager perspective, the system engineer needs to define the what. Now, there are circumstances where the system engineer needs to define the how. Typically, the difference between the what and the how is that the what is more about defining just the system architecture. The how is taking the system architecture forward and developing the system further in terms of detail. Defining the subsystems, the assemblies, the components, and also sub-assemblies, and obviously the definition of the parts. So this how here is when we move from some form of physical design, which what the industrial design people usually do together with the system engineer and the mechanical engineer, and then you move from the what to the actual detailed design, and this is when you move from the what to the how. So when we get into the detailed design and we do really detailed development. Now, I'm not sure whether you've already seen the V model. The V model is one of the ways of modeling the entire walkthrough of our system. So it's the equivalent of the life cycle of the system. For example, the one that we saw for the 15288, but it's also a very useful way of making sure that you develop the system the right way, in the right sequence, and with all the right detail. And it's called the V model, not because it's shaped as a V, although a lot of people think so. The V is actually coming from a definition of the originators of this V model, who were German. And in this particular case, the V is actually coming from a word which actually means process, believe it or not. So when we speak about V model, remember that V model is not the shape as you see here indicated in the picture, although it's easier to reference, of course, but it's because we're speaking about process, and that V is coming from a German word that starts off with the word V. So what does this process say? Actually, it's actually classified as a V model. I would actually hesitate to define it as being a model. I would prefer to call it a framework, because it's a framework that includes certainly a model. It also includes a collection of processes, but it gives you a high level picture of what you would do to develop and retire a system once you've decided to take it away from the marketplace. So it starts off with a phase here that in this particular schematic is defined as phase -1. And here we are looking at a V model that's been used for a societal architecture, believe it or not. But it's more or less the same also for engineering systems, so products and services, for argument's sake. And you can see that you go through a collection of phases, and you go through a collection of verifications and a collection of validations to come up with a successful system, and then deploying the system in the marketplace. And then after its usage, it's operational, you would then retire the system and dispose of the system in somewhere. And you have along this journey here that's indicated with this V, a collection of decision gates. If I go back one slide, when we move from something that includes functional design, physical design, and then detailed design and development, what I'm saying is that we're going from possibly here to this thing about detailed design. And then we move forward to do things like unit testing and so on. So this is the V model. You can get various versions of the V model though. The one that we're seeing now is a high level picture of a system, but I could use the same V model in terms of discipline. So I could have a V model for each one of my disciplines within the project team, so mechanical engineering, electronics engineering, and so on. And therefore, you imagine seeing a collection of V's, one on top of another. that would be defined as being a 3D V model. Here what we see therefore is a 2-dimensional V model, and this one is specific for systems or systems engineering. Now, everything okay? Do you need a break in about 10 minutes? Is that okay?
Yeah, also would be good. Thank you.
Okay, good. Let me move on. We've got roughly about another 10 minutes. So I mentioned this thing about the IPO diagram, and the IPO diagram, it's the simplest and possibly the most well-known diagram to map process. And IPO simply means inputs, outputs, and the P, the letter P in between, is what we have in this central box. And although generally the central box is defined as being the activities box and the tasks box, but nevertheless it could be a process or it could be a collection of processes that are interconnected between each other. If we look at something like this, then clearly we could use this diagram to map any process. And that could be also for non-engineering purposes. Have you ever used an IPO diagram outside of the what you see here in this particular picture? Have you seen it applied elsewhere?
No.
No? Okay, well, let me just add the other two boxes, which are controls and enablers. Let's do a very quick exercise together, okay? This is not the official exercise that we'll do after the coffee break, but this is just to get us thinking. So if we're going to organize a Zoom call or a Teams call, or I don't know, a Google Meet call, so we're going to organize a video conference, what would you actually put in the inputs box here? What would you need in order for you to start the definition of the process for organizing a video conference, whether it be with Zoom, Teams, Google, or WebEx? So what would you actually stipulate in terms of expected inputs?
The time availability of people needs to attend the meeting.
Okay, but yeah, okay. Can you so when you say needs, do you mean things like the topics?
No, the availability, like if we have to organize a meeting, then one of the conditions that we need to organize the meeting is to know when people can actually meet. So one of the inputs to the process of scheduling a meeting is to know when people can do it.
Okay, so certainly that is needed, but we need to also establish maybe a title. What's what is the topic of, or what is the the key reason for organizing this call? We need to have an agenda. We need to set the topic or the topics, and we need to set the time maybe, and have some timing if we have an agenda. We need to think about the invitations as well. So we need to have, for example, an invitations list, maybe send the invitations. Expectations, I think, is another one. What are the expected deliverables? Here, we're not speaking about the deliverables in terms of the outputs, but something generic. For example, we need to decide on the decision that we need to have at the end of the process, for argument's sake. So, in terms of controls, what would you think you would need to have if we're going to organize a video conference in terms of controls? You would need to have, obviously, some form of acceptance from the invited people that they're going to be there. So you need to control this, you need to check this. So you need to have a confirmation, essentially. You need to have things like document templates. You need to have, for example, a safe connection. So, for example, a VPN connection. You need to have confidentiality maybe in place, because otherwise people would not be able to share documentation. You'll probably need some form of housekeeping rules. Housekeeping rules could be something like, please ask your questions at the end of the presentation of the work. That could be a housekeeping rule, for argument's sake. What would be the enablers in order for you to do this video conference? What would be a couple of enablers that you need to have in place before you can actually make this a success? Doesn't guarantee success, but an enabler in this case would allow you to have the actual conference. What would you consider to be
like a server?
Well, yeah, you need the hardware. So you need, well, I would imagine that you need an internet connection. You need PCs, tablets, smartphones, whatever it's going to be. If it's going to be a Zoom call, you need the Zoom software. Probably you need to have some documentation ready. For example, you need to have an agenda, so a slide, for example. You might be, it might be required to access maybe a repository, so something like Box or OneDrive or SharePoint or something. So you can see the difference here for a Zoom call or let's say a video conference, the difference between a controller and enabler. So the enabler is something that allows you to what you have in this box, and the controls are the things that will control maybe the quality and the output of what you're doing here. So what would be the activities, the tasks here? How would you define how would you define them here in this central box?
So there is.
I think if we have satisfied some passages that we decided before in the
yeah. So you'd have the list of topics here, for argument's sake. So this is an example of where that central box will probably mimic something that is already captured in the inputs, but nevertheless, there could be a series of things that are expected by you or from somebody else to be done here. And that is not always obvious. So, for example, when we come to list what's inside the central box, we need to have also here a clear idea of what is going to be tackled in the Zoom call or the Teams call or whatever it's going to be. So this is important. Typically, when online meetings become too confused or they get too long, it's because what was agreed here was not clarified. It wasn't clear for everybody, and it just got out of control. Typically, you see this when you see something like any other business. I'm sure you've seen in an agenda, any other business. Any other business, though, can mean any other business. So this is a typical example where maybe the Zoom call will get out of control. So you need to have the topics here, in the case of the Zoom call, clarified up front. That doesn't mean to say that you're going to have everything clarified, because it might actually be part of the activities that you do here. That's the difference between the activity and the task. Now we come to the outputs. What would be the outputs when it comes to a Zoom call? What would you expect? Any idea?
I expect some result about the business prevision.
So remember that we're thinking about organizing a Zoom call. So probably you're expecting some form of deliverables. You'll probably have maybe a minutes of the meeting. So after the Zoom call, somebody will summarize the Zoom call and put this summary in minutes of a meeting, so a MOM. You might have a list of open issues. You might have an actions list together with the actors that are going to do the actions, an ownership matrix as well. And one other thing, let's suppose it's going to continue with another call. You need to establish the next Zoom call, and therefore you need to establish the date and the time and who is going to participate and so on. So what we're saying here for the Zoom call is I've just simply filled out the IPO diagram as we've just discussed. Now, I can modify this IPO diagram to suit anything that I need to do in terms of a process using the IPO diagram. Now, essentially what I'm saying though is that we need to have something. What is the process? So I need to define the process. So it would be a title, and it would be Zoom organization process. What is the process for? To explain it. Who is involved? So the key actors, and here we could have things like departments, for argument's sake. And obviously, where do you use this process? So we use, obviously, because it's tied to something like organizing a Zoom call or video conference. So this definition here, this IPO diagram, can actually end up in the quality management process for communication. And obviously, I can mess about with my settings here. Can you see here I put 3 flags? So once we've done this process for our Zoom calls or Teams calls or whatever it's going to be, then I simply say, okay, I've tailored the process, it's been made to measure, and we need no further tailoring. If I decide to leave this open for future tailoring, then I could move this little smiley here to the second box. Or I could say, no, it's already been tailored, but we haven't decided yet to allow or not further tailoring. So we would just have a little indicator here. So we need some form of indication of if the process has been tailored, if it's been finalized, and so on. So I could change this wording here to suit my circumstance. Now, you saw me speak about the business requirement specification process. This is an example of the IPO linked to the BRS. And as you can see, this is a process that's being tailored. So let's suppose a company calls me in to do some consultancy work on how to improve their process, in particular their business requirement specification process. Then I would do something, for example, like this. And it can include many, many details. This is a high-level snapshot. So it's the IPO for the BRS specification. So meaning the BR specification, or the business requirement specification. And you can see that I've linked also the this particular process to the life cycle process that was in this particular company. So essentially what I'm saying here is that this process starts off at the beginning of the business opportunity and ends at the end of the business opportunity stage. And in this particular company, it's called the proposal generation stage of their life cycle of their systems. So you can see it's a very clear snapshot of what the actual BRS means for this company. Was that clear? We're nearly finished. I think I mentioned in the previous lesson this connection between systems and lean. I just wanted to emphasize here in red that, again, we're looking at systems engineering that emphasizes processes and people, but you can also see it in lean engineering. So there's a strong connection between systems engineering and lean engineering through this concept of process. So bear in mind that systems engineering and lean engineering usually work together in some way or another within organizations. Now, we know that when we do certain types of work, we need to come forward with some form of decision or maybe a collection of decisions. These are just ways of looking at let's say techniques in deciding something in systems engineering. Now, here all I've done is just split them into 6 different categories. So this is a schematic that more or less summarizes decision support tools and techniques. And I think this is part of your, the core of your actual degree course, is having something that allows you to make the best decision based on the information, the knowledge that you have there and then when you make that decision. In all processes, there is always at least one decision. So we need to understand what the decision support tools and techniques are. So what I've done here is tied to each one of these 6 categories, I've put together a collection of decision support tools and techniques. And this is just a high level picture of some of these tools and techniques. Have you seen some of these tools and techniques in your coursework so far?
Yes.
So there's nothing new. Interestingly, though, if we look at the lower right-hand corner where I speak about processes, I'm sure you've heard of benchmarking. I'm sure you've heard of things like just-in-time, Kanban, business process mapping, etc., or maybe process mining, etc. There's actually the IPO diagram as well. But there's also another type of program diagram that's called the IDEF0 diagram, and all it is an IPO where the process is replaced with a term called function or feature sometimes. So this is a high-level snapshot of some of the many decision support tools and techniques that you have available when it comes to looking at processes, and in particular the decisions that are made along these processes. So in conclusion, before we have our coffee, and I think we saw this in the previous lesson, we start off with an identification of some needs. The needs can be declared or they can be latent. There's several models. For example, there's a model that I developed with one of my past thesis students called Martha Larson, and we looked at the definition of needs in general, and we developed a model. But there's also other models like Maslow, Norwood, Hertzberg, and so on. And nevertheless, once you've defined the needs, whatever these needs are, you'll usually end up with something like ideas, problems to be solved, opportunities, etc., which are then collected in some form of portfolios or portfolio concepts for ideas, portfolio of solutions for problems, and portfolio of proposals for opportunities. And after this is actually put together, which would be more or less the end of the concept phase, you then move forward and you go into the actual development, if it makes sense from a business perspective, of the system, and then moving through the life cycle. And at the end of the life cycle, you would go back to the redefinition of the needs. So that is the first part of today. So we're going to do an exercise after our coffee break. Let's see what time it is. So it's 16:25. So we'll have a break for 10 minutes. Can you come back at 16:35? So that's 25 to 5. So in 10 minutes time.
For sure.
Okay.
Yes.
Okay. I'm here, by the way, if you need to ask me any questions. So if anybody is hanging on, I'm here.
Perfect. Thank you.
Okay. Thank you, David. So see you in 10 minutes. Thank you.
Okay. Was it clear for everybody?
Pretty much. Very much, actually.
Okay. Thank you, by the way.
And we are happy to see you today. So you
can see me.
Yes, you downloaded the application, maybe.
No, I tell you what, I downloaded the application, but the application didn't show me the files.
Okay.
So
how did you fix the problem with your webcam?
Well, what I did was I went back and I loaded the web version, and the web version, which was the version that I used the last time, is exactly the same version that I'm using now. So evidently it was a question of loading some of the drivers or something.
Okay.
In the meantime, I'll load the what do they call it? The exercise. Now, which one should we do first? Yeah, let's do this one. Actually, what we could do that other one. Yeah, maybe this one. Yeah, let's do this. Yeah, let's do this one. Yeah. So. I'll just take a break for 2 minutes. We'll be back in a minute. Ready? Dum, ba-dum, bum, bum.
Mr. Ward?
Yeah.
Yeah, I have a question. According to your work experience, which one was, if you found it, a developing project that created some issue in following standards and the classic way of developing stages? I do not know if it's clear.
No, can you repeat
Yeah.
the question?
We, as you were presenting to us, we have a flow stages to
Yeah. Okay.
develop a product or in the manufacturing environment. Did you find, for example, a particular new problem to develop in a company?
Yeah, I think I've got your question. Let me try and answer the question from a different perspective, and this is what I've said many times. Before the coffee break, we were looking at processes, and even though we actually didn't go into detail, just to give you an idea, to explain the technical processes, it would take me roughly a couple of days to explain the technical process, so the real content. Nevertheless, irrespective of whether we're speaking about technical processes or non-technical processes, what a lot of companies don't realize is that they always tailor their processes. What does this mean? It means that the process in somewhere is modified by somebody or maybe by an organization within the company, and the company doesn't realize or recognize this. So what happens is, ironically, the company is not aware of their normal way of doing things, and when it comes to understanding the processes that they claim to have and actually follow, in practice that is not the case. So what does this mean? It means that when something goes wrong in a project, or maybe when something actually goes really well in a project, more often than not, it's usually not captured in one or more processes, meaning that there's usually an investigation. For example, when it comes to lessons learned in particular, I would say in the Western world, we look at lessons learned from a negative perspective. We rarely do we look at it from a positive perspective. So when we analyze something from a forensic perspective, when something goes wrong, in other words, we then realize the importance of processes, and maybe something that should have been done that wasn't done, maybe the quality of something that was done wasn't up to the standard that was needed, and so on. So in general, my answer is companies always tailor their processes, so they modify their processes. The problem is that this is never documented, and unless there is something negative as an outcome. So I suggest always to customers to start off with something like an IPO, to understand at least one process that is impacted, or maybe that is done to carry out a certain type of job, and go from there, and maybe connect the adjoining processes to see how they're actually interconnected, because that's also another issue as well. Companies don't realize that processes that are apparently different and far away from each other, that actually are connected in some way, and that connection could be through the project, through the people, or through another process.
Okay, thank you.
That what was did I give you an answer that was understandable?
Yeah. Theoretically, yes. Thank you.
So my suggestion is always to map out the processes. You'll actually find that certain processes that are claimed to be done in sequence are never done in sequence. Okay. They're actually done either in parallel, or maybe there's a disconnect. So, for example, we'll let, for argument's sake, we'll update the requirements once we've finished the definition of the system architecture. So at the end of a process, well, in reality, it should be done as you're going through the process, in this specific case, at least.
Got it.
Just let me close the door because the doors come open. So can we restart?
Yes, David, I think that we can restart the lesson, and
yeah, I've added an exercise here, or rather I've chosen a different one with respect to what was my original plan, and it's called the user journey. So what we're going to do this together, by the way, and we're going to emphasize the importance of understanding the user journey. And you can compare this user journey also to the technical processes that we witnessed before the coffee break, meaning that things are done in a certain way. And it's particularly useful to look at the user journey because you can also see very important elements of where you can actually lose business potential, lose business opportunity, or maybe you focus on something that is important, but not necessarily the most important of this user journey. So, so what we have here is a problem statement. It's a washing machine. So we're going to look at a washing machine. I think everybody in some way has looked at a washing machine, either from a user perspective or maybe from a purchasing perspective, etc. So what we're going to do is we're going to redesign through the user journey, or the definition of the user journey, the whole washing experience. So we need to think together about the entire journey that the user takes before and after using the washing machine, and therefore not just the washing process in itself. So we're going to list and explain the steps that you need to see and take. And therefore, from this journey or this process, connect the steps, and from there progress to understanding where the business opportunities are. So, can I ask you to give me some of the key steps before you actually use the washing machine, and after when you've finished using the washing machine? So here, the washing machine is just dealing with the washing process, etc.
You have to put in the chemicals that are needed to clean the clothes, and you have to choose how much and what kind.
Yeah.
You have to put the clothes inside.
Yeah.
You have to choose the program.
Yeah.
Depending on the machine, you also have to specify how much to set the centrifuga to the spinning to let the water out.
Okay.
And then when that is finished, unless it's not automatic, you have to have the water go away.
Okay.
And then you have to take out the clothes.
Okay.
And eventually put them where they can dry.
Okay, good. Now, if we were speaking about the washing experience, where washing experience means the entire journey that the user takes, what else could you think of? Because you focused a lot on setting up the washing machine, using the washing machine, etc. What actually happens before you do something like this and afterwards, once you've used the washing machine?
It has to be collected, all the objects that have to put aside.
So you're going to have to separate the clothes in some way, maybe also as well. Yeah.
Yeah, maybe this process can be optimized as well as possible in an automatic way.
Yeah.
But there is a user that needs to do that.
Yeah.
And also, just before the starting of the program of the washing machine, maybe I lack of imagination, but I cannot imagine something different from that one was explained by my colleague.
Yeah, don't worry, because I did this exercise for the first time, I think it was 1996. And I was working for a company called Whirlpool. Whirlpool was, and I think still is, the biggest washing machine manufacturer in the world. If it's not, it's certainly in the top 5, together with Koreans and Chinese. Nevertheless, one of the reasons why we decided to investigate this was we wanted to understand the entire journey that the user was taking before and after using the washing machine, to help the user to use the washing machine or have a different washing experience. And you'll see in a while that an enormous amount of business potential was actually uncovered because of this research work. It was thanks to this project that I got my PhD as well in fluid dynamics, believe it or not. So anyway, did somebody think like this? Okay, you might not have thought of this as being part of the washing experience, but certainly there's a connection to the washing experience. Why? Because you said that you need to select your clothes before you actually put them in the washing machine. So you can't sort of like combine, I don't know, something that has very sensitive and expensive fabric like silk, for example, with denim, for argument's sake. So something happens beforehand, well beforehand, that defines in some way what actually goes into the washing machine. So you'd choose what to wear. So, for example, in the morning, you would then wear your clothes, okay? And depending on where you wear your clothes, so if you're working in a garage is one thing, if you're working in an office is another thing, and this will obviously in some way dictate the type of washing cycle that you're going to need later on, because depending on the type of soil, meaning the type of dirt and so on, and how intense it is and what type it is, you're going to establish the preferred washing cycle. You'll obviously wash your clothes, and then you're going to dry your clothes, and you can dry your clothes in many different ways, of course. After the drying, you're probably going to have to iron your clothes in some way. Ironing here means actually putting the clothes back into the original, let's say, state that they were in at the beginning when you decided to choose the clothes. You're going to have to separate your clothes anyway, because once you've ironed your clothes, you're going to put them maybe in different parts of your house, different drawers, different wardrobes and so on. And therefore, you're going to store your clothes in somewhere. And from the storage, you restart that cycle. So this is an example of capturing at a very high level the user journey for this so-called washing experience. Now, I can focus on specific parts of this process, or I can continue. Now, if we are going to continue with this idea here, how else could you actually picture this process now that I've opened your mind a bit? And now you can actually see the value of not looking at the washing machine, but you're looking at a washing experience. You're looking at it much more systemically rather than something that is very systematic, therefore looking at the washing machine. So what else could you imagine taking place in this journey here?
Well, since we are enlarging our scope, I could say that we could choose what to buy. So
certainly, yeah, that could involve also what to buy. Yes, yeah. Actually, that usually happens because when you buy something, you'll obviously look at the price, but you also look at things like how much it's going to cost you if you take it to the dry cleaners rather than wash the things by yourself. Maybe it's just one for one specific occasion. For example, when you get married, or when you have, I don't know, when you go to a certain ceremony, for example, maybe certain clothes you only wear them once, or maybe just 2 or 3 times, which means that you actually probably won't wash them again. So certainly we can extend now our experience and include things like purchasing. If we were to look at this process in a more graphical way, you might come up with something like this, though. Did you think of something like this?
Not at all.
Now, I can make this even more complete and complex. Nevertheless, now you can start to understand that when we speak about system requirements, and this system is a washing machine, we need to understand the stakeholder needs, but we need to understand the business requirement specification and the business needs, meaning the market needs. And as you can see here, we're not looking at just a washing machine anymore. We're looking at something which is much more open and much more extensive. And I think you can start to understand now the business potential. It goes beyond our concept of the washing machine experience. For example, I'm sure if you're married or if you've got a girlfriend, or maybe you're living by yourself, one of the things that you hate to do is doing ironing, folding, separating, storing, and so on. So there's a lot of business opportunity in each one of these boxes. I can actually split these boxes into at least 3 or 4 different other things as well. Just to give you an idea in terms of business potential. So this is some recent data. So the global washing machine business or market is going to be worth by 2027 $53 billion. Look at the figure for China, 7.7 billion. 7.7 billion. So the rest of the world is taking up more or less about 45 billion, 40 something billion. That's an incredible number. If we were to extend our vision of the washing experience, we were to think about dryers for argument's sake, that's worth more or less about 1/10 of the washing machine business. So if we were to develop a system that would be acceptable and in line with the expectations of the washing machine user, then they would probably buy a dryer also for their washing machine. Or maybe if we could have a function, a drying function, like you mentioned spinning for argument's sake, then this would be included in this 53 billion marketplace. Just to give you an idea as well, look at the difference between the washing machine business and the apparel market business space. Look at the difference in value. 53 billion versus 1.3 trillion. And it's going to rise to 1.5 million by the end of, well, it's now last year. 1.5 trillion by the end of 2020. Yes. So look at the factor between the washing machine business and the apparel market. Said in another way, if you're going to use a washing machine to treat the garments in this market, okay, you can imagine the value, how much it might cost you if you get the wrong washing cycle, because it's just simply a division here of the value of the typical value of the clothes that you put in the washing machine. Another interesting figure is this, the washing machine, the number of units per annum, 170 million units per annum. Just move that out of the way, sorry. Which means about 450 to 470,000 units per day. That's 5 units per second. So just by looking at this slide, we probably filled the entire building where you are now with washing machines. That's the magnitude of the of what we are producing right now. And that's an astronomical figure. So you can imagine if we were to look at the entire journey. Why is it not going forward? Sorry. There we are. So people have obviously looked at the that entire journey. Here are a couple of ideas that are either on the market or are about to be put on the market. So this particular idea is to wash clothes manually, and it's an ultrasonic device. And this tackles the issue of needing to wash just one garment maybe, rather than wait until you have 5 or 6 kilos to put in the washing machine. This is a similar idea, but it's essentially doing two things. One, it's reducing the workload, and it's tackling the workload in a different way through this idea of modularity. So you have the same washing machine that you'd probably buy and that you have in your house, and it's in combination with a deliberately developed washing system that has a smaller workload. Can you see that? Other interesting things. So when we look at the business space, remember that somebody mentioned setting up the washing machine. Why do we need to set up the washing machine? Can this not be done by the washing machine itself? For example, through intelligent tags on the garments. You can develop an automatic ironing system like this one here. So this is actually on the marketplace, by the way. Somebody's actually looked at other ways of improving that process and exploiting that process of the washing experience. So using an ironing table as a mirror, an ironing table which is actually part of the decor of your house, so with a mirror again. That's it closed here. And this is a very clever idea. When you actually iron your clothes, this is a see-through iron. Can you see it indicated on the right-hand side?
Yeah.
Now this device on the left-hand side, when I was doing my PhD, I was actually working at the time for Whirlpool as a systems engineer, and we developed this system, not exactly this one, but something very, very similar. And it wasn't a washing machine. It was a machine that was taking the smell away from the clothes. Why? Because we were developing a system like a closet, which would both eliminate the wrinkles from the fabric, as well as deodorize and make the clothing nicely smelling for the next day at work. This was developed for high volume restaurants or people working, for example, in kitchens, etc. So it wasn't a washing machine, it was a deodorizing machine. Why? Because we looked at that entire process that we saw beforehand. We asked ourselves the question, why do we need to put our clothes in the washing machine? In other words, why do we need to wash our clothes? So when we look at the user journey, now we can start to look at other key things. I believe I showed you this in the previous lesson. This is the user journey, starting off with the definition of some form of usage or why you need to have the system. In this particular case, it's a walkthrough for a medical device. And it starts off with a pre-diagnosis. So you have some form of symptoms, and afterwards the doctor, after the doctor visits you, will come up with a diagnosis. From the diagnosis, you will get some form of treatment. The treatment is applied, and then you are normalized, meaning that you're healed, or your state of health is actually normalized in some way. And the business case, if we just focus on the medical device, is just tackling one of these elements of this journey here. So the business space is very limited. So if you have somebody in the family, or maybe you are suffering from asthma, you need to take this drug here, and usually it's from an inhaler, as you see here. But that is just a device that is developed for this moment here in this journey, meaning in this part of the business space. So when we look at the business requirement specification, when we look at the connection between the market needs and the business case, we need to understand the complete journey. And that's why you have the stakeholder requirements assessment. That's why you have the system requirements assessment, and so on. This was an interesting device, actually, that I developed together with my other colleagues, and it was a system that was based on powder. So this inhaler here is the equivalent to what you have here. This is done with a gas. This is done with a powder. And the interesting thing about this is that it was connecting to a mobile device so that it would make sure that you're taking the medication at the right time. In fact, when we think about the user journey includes the user flow. For example, it also includes the usage flow. So for example, that explanation that was really clear about that we needed to select the cycle, the washing cycle, put in the detergent, switch it on, and then do the actual washing is part of this entire journey that you see in this yellow box. Then we have the user flow, which is a subset of the user journey. And then we have the usage flow, which is usually what is done by the user in using the device. And you have other things such as events. So you would have, this would be connected to things like risk management and so on. Specific examples that are known as corner cases and maybe examples of misuse. So it gets back to what we were saying before in that journey. And that journey is exactly the one that I mentioned at the beginning of today. So when we develop a system architecture, we need to go through these stages here. And also beyond, particularly in companies that have just started off with systems engineering. Why? Because the systems engineer usually has also other responsibilities along the system lifecycle journey. So we need to think about system lifecycle, just as we saw for the washing experience. I'll close with this slide because this is a very good example of the connection between systems engineering and industrial design, as it's brutally called today. Industrial design is just one element of that complete picture that you see on the left-hand side. And here what you see in terms of systems engineering is that V model that you saw earlier today. And there's a connection between industrial design and systems engineering because here the industrial designers are looking at the features and the functionalities and how the user intends to use the system. The systems engineer takes the needs and translates them into requirements. And from the requirements, you develop things like the system architecture, the system detail design, and so on. So was that clear for everybody?
Yes.
Yeah?
Yes.
Did you enjoy that? Was it was it an eye opener for you?
Yes, even more considering that I thought that I got the difference of systemic and systematic before this example.
Yeah, and remember the swimming pool as well.
And then I stepped right into the trick, and I thought more in a systemic rather than systematic rather than systemic view.
And now you can start to see the benefits of systems engineering, and you can also see why, as system complexity increases, there is little option for us to move also in the direction of systems engineering. I'm not saying it is the solution, but it's certainly one of the best solutions, at least what we have today in terms of developing systems, whether these be products or services, or maybe products and services and so on. So this final part of today, we're going to look very quickly at systems engineering standards. But before that, I'm going to introduce the concept of standards. Now, if you have time, I suggest that you look at this video. It only lasts 2 minutes, and it's by the ISO standards people. And here they justify why we need standards, and in particular why you need international standards like ISO standards. It's a very good video, very quick. I say it's only 2 minutes, so it's not particularly important. And the video is actually on the on SharePoint. So a bit of history about standards. UL, which is the Underwriters Laboratory people in the US, which is a very important and famous standards body in the US, but not just in the US, it's also across the world. This gentleman here called Henry Murrow was the one that was given the let's say the job of understanding the risk, the fire in particular risk, of participating at the World's Fair Palace of Electricity, way back at the end of not the last century, but the previous century. And from his work, this organization called the Underwriters Laboratory, or just as it's called, the UL people or organization, was put together. And there's a very interesting timeline that I recommend you actually look up. There's a reference here if you want to understand more of this detail. But they started off with the investigation of things like fire doors. You see it here? But this was more about the consequences of a failure, in this particular case, a fire door. It wasn't really about a standard or safety. It was about the repercussions of the lack of safety and the lack of standards. While the real key move forward was done by BSI in the UK. And one of the reasons why BSI started off was because there was a realization by not just the British authorities, but in general, that everybody was developing their own standards for railway track. So BSI are the ones that are classified as being the ones that have started off the real need and identification of the need for standards. So BSI means British Standards Institute, and this was initiated at the beginning of the last century, when they were investigating and standardizing, meaning that they were reducing the number of types of railway track section, which at the time I believe was something in the region of something like 70 plus different sections of railway track. And the British government said, no, we can't accept this. This is just too expensive for us. So we need to standardize. And lo and behold, the BSI people were founded to do exactly this. And then more or less 50 years afterwards, we had the birth of the ISO organization, the International Organization for Standardization, but also other key standards bodies. I haven't mentioned all of them because there are quite a few, but for example, CEN, which is the European Committee for Standardization, or let's say the European version of ISO, that was set up in 1961. And if you think about it, that was a very important landmark because then we didn't really have the concept of Europe, and therefore the concept of European, of something European in terms of standards. So these are three key, let's say, moments in the development of standards. Now, I'm not sure whether you know this, so I'm going to say it. Do you know that standards are not compulsory? Did you realize this? Or did you automatically assume that the standard was compulsory?
Yes, I thought that was a mandatory.
No, a standard is, as the word says, it's a normative approach to agree on something that usually is connected to either certification or testing or something, or maybe a quality level for a product or a service. So in reality, a standard is not compulsory unless two things occur, or maybe just one of these two things, but generally they usually work out together. One is that it's included, the standard is mentioned in legislation. So it's part of a law or a decree or a directive, like a European directive. So if it's in a law, it is compulsory. If it's not in a law, then it's not compulsory. The other way of seeing the fact that the standard is necessary is when you look at it from the marketplace perspective. So maybe the market is expecting that the product has been tested versus a certain standard. So this gets back to this thing about testing, certification, and quality. A good example is the emissions for your car. So Euro 4, Euro 5, Euro 6, or 6B, and so on. Now, nobody would buy a Euro 4 car in Europe, at least. Nobody, unless there's no restriction on Euro 4 where you actually live or where you intend to use the car. Why? Because the marketplace is dictating that the car that you're going to purchase, that you've bought, respects certain legislation, such as gas emissions for cars. But nevertheless, it's a marketplace requirement. So you think of standards as being something that is not compulsory unless the standard or the standards are actually mentioned in legislation. or in the market, in a marketplace requirement. And therefore, when we speak about business requirements, we need to speak about standards. Why? Because either from a legislative perspective or from a marketplace perspective, there's going to be a connection. There's going to be a need to be satisfied. In this case, it would be the certification towards a certain standard. Now, you might also be surprised to know that a standard doesn't guarantee safety. What it guarantees is that the product, or maybe the component or the part, is being tested towards a certain normative way of looking at a test procedure, and therefore you satisfied that test protocol, that test procedure. What you see here on the right-hand side here, I'm not sure whether you can remember this, a couple of years back, there was the famous fire in London. Can you remember this?
Yes, I think that was something that happened in the late 1999.
No, it was only a couple of years ago, to be honest. And that gives you an idea of, maybe you're thinking about a different fire, but nevertheless, this fire is very, very, it's been investigated many times now, but nevertheless, even though it's a recent incident, but the fire started off at the 4th floor, where I'm indicating here now. And the reason why the fire propagated to the rest of the building was through the external panels of the actual building. The panels were tested individually, and they were classified as being safe, but they were tested one panel at a time, not in the installation. So when we look at those technical processes, there is a process where we look at things like implementation, where we look at validation and verification. This is the perfect example where if you just one component, the system can still fail. Actually, more often than not, a failure is usually traced back to a component or part in the actual system. And interestingly, I'm not sure whether this works or not. Doesn't. No. Anyway, you can actually open this file and you can hear the emergency services responding to the actual fire call, so the actual telephone call that they received. And at the time, the procedure for fires of this type, the fire services in London, but also in the UK in general, recommended that the people stayed in the building until the fire services arrived. Why? Because people were running the risk of dying because of intoxication from the fumes, meaning from the smoke that was generated by the fire. And unfortunately, that was the worst decision that could have been made, because many people, including, I believe, 2 Italians, died in this fire. Also, standards are there because you need to harmonize something, meaning that you come to an agreement. That's why we have European standards. And now that we have Brexit, we were starting to appreciate, well, the people in the UK are starting to appreciate why harmonization is so important. Because if you have differences in standards, then you can have products that are rejected because of this lack of harmonization. And remember also that standards can be used in terms of tariffs. Chinese, for example, have been using standards to make sure that their manufacturing facilities are ahead of the competition, because they are using standards, their standards, as a way of including tariffs through the necessity to test the product versus Chinese standards rather than European standards. This picture here, does anybody know which what bridge this is?
The Millennium Bridge.
This is the Millennium Bridge, and it's also another failure from a standards perspective, because the Millennium Bridge was defined and it was designed versus a standard, a building standard, that was out of date. And they discovered that it was out of date when they actually tested and validated the system. So they opened the bridge, and within a matter of days they had to close the bridge, because the natural frequency, the walking frequency of the people that were using the bridge was almost, if not identical, to the resonance frequency of the bridge itself. But there was no standard for walk across bridges that stipulated that the structure had to be, it had to pass a certain test, which would be this resonance test. So what they had to do, they had to close the bridge down. Literally, nobody could use the bridge, and they had to include and redesign the final two ends of the bridge, and include enormous dampers that would then offset the natural resonance frequency of the bridge, sort of like enormous shock absorbers. So if you ever go to London and you go and see the Millennium Bridge, go and see the size of the dampers. I mean, they are enormous, literally gigantic. And this was because when the bridge was designed, it was designed versus a certain standard, which unfortunately was out of date. It didn't suit the purpose of the actual design in this case. So let me move to the next slide. There are three levels of standards. So we have national standards, like in Italy, UNI standards, or UNI standards. We have regional standards like European standards, and we have international standards. So there are three levels of standards. So not necessarily do you have a standard that is accepted at the national level is the equivalent of an international version of the same standard, and obviously also for regional standards. So these are not necessarily progressive or inclusive. Actually, you'll probably find that when you come into the discussion of tariffs, they're actually exclusive. So one standard that is applicable in Europe might not be applicable in China. One standard that is accepted in China might not be accepted at an international level, and so on. Did you know this?
Yes.
That is something, it can make a very big difference when you design a system, particularly from a system architecture perspective. Another interesting thing, this is a high-level summary of the life of a cycle, the life cycle of a standard. So here we would start off with a need, the identification of an idea. So we'd have idea generation, and this would be the complete loop that you will go through to develop and publish your standard. Typically, starting from now, it would take us something like 5 years to develop a standard, roughly about 5 years. Super fast ones you can take up to 2 years, really national crisis types of standard, meaning standards that have been developed versus a certain crisis, might take up to something like 1 year. The interesting thing is that the average life cycle time of a standard is between 5 to 10 years. So that's a long time. So if a standard is issued now, so in 2021, it will be reviewed in about 5 years' time at the let's say the earliest date. So if we think about the 15288 standard, which is now being revised, it was issued in 2015. So they started the review process, and it should finish in about 2 years' time. That's how long it takes to develop and review a standard. Other interesting about standards is that you might think that an international standard is accepted everywhere, but that is not the case. These are a couple of pictures. For example, ISO standards are not accepted in Greenland, or let's say not as is, certain parts of Africa. There are certain areas also in, for example, in the Vietnam area. No, not Vietnam, sorry, Korea area, but also the Balkans here. Oh, sorry, not the Balkans, the Persian states. IEC also doesn't have a world coverage, just like Senelec. ETSI, which is the communications type of organization for standards, and CEN. Also, another interesting thing is what I've just mentioned. This is for the 6601 standard, which is for electrical safety in medical devices. The last edition was 2014. Now they're just about to issue standard number or edition number 5. The Chinese, I think they are still hanging on to version or edition number 3, if I'm not mistaken. So don't think that a standard will be automatically accepted by all organizations and by all nations, because that might not be the case. We are aware of this geographic dispersion of or inclusion or exclusion of standards. That's an interesting map, that. So when we opt for a standard, we need to make sure that we're speaking of a standard that might not be geographically accepted in the marketplace where we're going to launch that product or service. When we look at the business requirement specification, the stakeholder requirement specification, and the system requirement specification, we need to have a clear picture also from this perspective. If you're interested in the development of systems engineering standard, even though this is now this is a publication that I put out 3 years ago. Actually, I've decided to update this schematic that you see on the left-hand side, but it's the one that's reported in this document here, and I've also made this available as well on the SharePoint in the SharePoint folder. So if you're interested in the development and the metamorphosis of systems engineering standards, I'd recommend that you look at this publication. Moving up further forward, looking at some of the interesting timelines for different standards in systems engineering, you can see that there's an enormous dispersion, and this is just a selected number of systems engineering standards. So we're going from anything that is considered, for example, as being the father of systems engineering standards, which is the 49.9 standard, which is a military standard that was first issued in 1969. It had something like 30 pages, of which at least 10 pages was saying nothing. It was just something like the front page, the signings page, the introduction, the applicability page, definitions, and the rest was really the standard. So this was a very high level standard. And you can see that other standards are mentioned here, like, for example, the 15288, where is it? Here. And the current edition is 2015. And this also includes software life cycles as well. So that's a very high level picture of the timeline for systems engineering standards, key standards. Just to mention, so I'll go back one slide. Can you see here that I've reported the 24/748 standard, and there are several dashes, -1, -2, -3, -4. I've actually provided also this slide, which is specifically about the 24/748 standard. And you can see that there are other dashes. So we've got -6, which is about system integration engineering, -7, systems engineering in defense programs, -8, which is about technical reviews and audits in defense programs. So there is an expansion now of systems engineering standards, even just for this specific standard, which is the 24/748, through this idea of dashes. This is the journey of the Systems Engineering Handbook, which started off in 1998. So if you think of that 499 standard, which was issued in 1969, before we actually issued a handbook, at least the Incosi people, the first one was issued in 1998. So that, that's quite a good number of years after the 1969 for the 499 standard. And now we're working on the 5th edition of the Systems Engineering Handbook. Currently, the one that is used today is this one here, which is the one also used for the certification of systems engineers, meaning the final exam. So they're working on this right now. This is the structure that is being leveraged to develop the next version of the handbook, and it includes these things here. So they've identified, so they've actually used the systems engineering process, and they've identified 700, if not more, user needs that need to be addressed in the next edition of the systems engineering handbook by Incosi. That's quite a few new user leads, and that's in the space of 5 years, by the way. So how do you access standards? Now, the vast majority of the standards bodies, so ISO, IEC, IEEE, etc., actually allow you to look at the standards, not all of the content, but selected parts of the standard. And a good one is by ISO, and it's called the Online Browsing Platform, or OBP. So if you go into Google and look for ISO and include OBP, you will come along to this page here. Here you can put in the standard that you're interested in, for example, the system architecture one, so the, I don't know, the 41,000 for argument's sake. And you will end up with a picture like this one here. Which one? This was the 15288 search that I did. And you can capture some of the key elements, as you see in this table of contents. And you can get a preview. You can't save anything, by the way, but you can get a you can get a good preview of the standard, even if it's out of date. So I suggest that you look at the ISO, the OBP search function, and just look at some of the standards that I've mentioned, which you can preview them. Now, the interesting thing about that loop that we saw previously is that the ISO, for example, indicate where it is in terms of life cycle of the standard. So right now, the 15288 standard is being reviewed, which is what I mentioned previously. It's being reviewed by a specific technical committee, and this technical committee is composed of industry representatives and also other institutions like INCOSE. So we're now looking at the review of the 15288 standard, but until it's actually published, meaning that we get to stage 95, as it's called by the ISO people, then it's the current one, the 2015 version, which is still applicable. So we're going to have an exercise in a while, but I wanted to ask you a couple of questions here. So is a standard compulsory? Is it true or false, this statement?
False.
False. In general, a standard can take less than a year to develop.
False.
False. The V model originated in Gran Bretagna or in the UK or Great Britain. Is that true or false? False, yeah. Adherence to a standard does not guarantee safety.
Yes.
Yes, true. Safety and security are different. Now, maybe I didn't mention this very well. Is this true or not? Do you classify safety and security to being different?
Yes.
They are different. Now, I can tell you, and I think I mentioned this in the first lesson. Being Italian, you've got a language difficulty here, because the translation of safety and security is sicurezza. So it's difficult to distinguish whether you're speaking about safety or security when you use the word sicurezza. So now the word sicurezza, at least in the engineering fields, people prefer to use safety and security to distinguish between the two. But you have also the same problem in other languages like Norwegian. They can't define or can't tell the difference in their language between safety and security. So they also use the English versions of safety and security. There are currently 14 technical processes identified by INCOSE. Is that true or false?
True.
True, yeah. Moving on to 7, safety standards guarantee also product security.
False.
False. Yeah. The first technical process concerns the BRS, the business requirement specification.
Yes.
Yeah, true. The 15288 standard deals with software only. True or false?
I think false, but I do not remember clearly.
Yeah, it's false because the 15288 standard contemplates both hardware and software systems. So this is false. The INCOSE in the 15288 standard are paired, meaning that they are, when I say paired, I mean that they work together, they are matched in somewhere. Is that true or false? They actually are paired, so this would be true. A decision support system is applicable only to system architectural decisions.
False.
That's false. Why? Because decision support systems or system can be applicable to any moment, or maybe even more than one moment in our system life cycle. So these would be the answers. So you got them all right. So that's good. So now we're going to do a quick exercise to finish off the day. And then we're going to have a sort of like a round table. So let me move to the next exercise. Was that clear for everybody?
Yes.
Yes.
Yes, for me it's clear.
So can you see my slide deck? It's called the IPO of making tea. So we're going to go back to the IPO that we saw previously. What we're going to do is we're going to use the IPO to essentially map the tea making process. So we're going to define the inputs, the tasks, the outputs, the controls and the enablers, and we're going to do this together. So these are the different types of tea makers and accessories. So quite a few. Has everybody seen this type of tea maker or accessory making teas?
Yes, there are different tools.
Very, very different. They've got different purposes. One, for example, includes a real user, meaning the operator in this case. But it's not the end user, the one that's going to drink the tea in this case, although this person can actually taste it and so on. So let's start off with 5 simple questions. What do you expect to be given or already have? So here we're looking at the inputs of our IPO.
I would expect to be given to already know what flavor I would like to have.
Okay, so what questions would you ask? So if I was to say to you, fill in these bullet points here, what questions would you spontaneously ask yourself? Or maybe ask before you can actually define the IPO for making tea.
What flavor would you like?
Yeah. So what type of tea? Yeah. I mean, like, you mean green tea, black tea?
Yeah, exactly.
Okay.
And maybe
Breakfast
also the type of tea, because, well, I don't know, maybe in England not, but if you ask an Italian if you would like some tea, you could also think like cold tea.
Cold tea, yeah, yeah.
So maybe you also ask, would you like flavor, and also what kind of tea would you like?
Yeah. What else?
Add something like sugar or milk.
Yeah. So the add-ins, I would classify these being the add-ins. So sugar, milk, lemon, or maybe none at all. Some people don't like anything in their tea. What else? What else? What else would you expect to be given or already have? Alessandro?
I think about the couple, la tazza.
Yeah.
The type.
Yeah. Anything else? Oh, sorry. My picture's gone. Where's my picture? Are you still seeing? Oh, there it is. Okay, it's come back.
Yeah, we can see you.
Yeah. Ali, what would you say? Well, you would, for example, you need to know how many are going to drink tea. You need to know who is going to drink the tea. You need to have things like water. So just as you mentioned the thing about the add-ins, you need to have the water, you need to have the tea and so on. So the inputs, there's quite a few inputs there. So let me now think about the outputs. What is the expected outcome?
To enjoy the tea that I have chosen with the add-ins that I have chosen. Yeah,
certainly, yeah. So there would be an expectation to have fresh and good tea, etc.
In a timely, and I would expect it to have it in a timely fashion.
In a timely fashion, yeah. So what you've just said is, allow me just to backtrack a second. We need to understand the purpose of the actual process that we're mapping. In other words, if I was to focus on the outputs in terms of what is needed for me to take, for example, the tea from the kitchen to the dining room, or for example, if I'm in a restaurant, in a bar, then the expected outcome would be different. Meaning that if I'm the one that's making the tea, even though there's a certain expectation from the end user, I might have to think about, well, I need to remember that I need to take the sugar, I need to take the milk, I need to take the lemon, I need to obviously take a teapot if it's going to be served in a teapot, or something that will actually keep the tea warm, so the tea cozy. I need to think about the teacup and the saucer. I need to think, therefore, about bringing the tea freshly, meaning that it's ready to be consumed. So bear in mind that when we look at an IPO, when we look at a process, we need to understand what is the scope of mapping the actual process. And that doesn't seem to be a big thing, but if I'm sure each one of you have done some form of mathematical model. One of the key things that you need to do at the beginning when you decide to model something is to explain what the model is going to be used for, meaning what is the purpose of the model? What is the expectation of the model? Are you doing it for a specific reason? What is that reason? And then you would add things like what are the accountabilities, not the accountabilities, the assumptions for that particular model and so on. So it's exactly the same as you see in an IPO, meaning you're mapping a process with an IPO diagram. You need to understand the scope of the exercise, meaning the scope of the mapping, because you can get completely different scenarios. So I think the outputs are fairly clear. How are you going to make the tea? What is the actual process? Can you remember the example that we saw about the washing machine? How are we going to make the tea?
Maybe we have to consider if it's going to be an automatic process, so
yeah.
Or if it is a manual process. So if I just push a button in some kind of machine and then I will have the coffee how I want it, or if I have to take the boiler, boil the water, put it in preparatory cup, put the actual tea, and then translate and transpose the tea from the first recipient to the actual cup.
So I think everybody agree with me that how we're going to make the tea, we'll probably need to fill the kettle with the water. We need to clean the teapot if we're going to use a teapot, or at least maybe clean the cup where we're going to put the tea. We need to boil or heat the water. Maybe somebody doesn't like the boiling water. We need to prepare the tea service. We saw that service where there was a lot of different types of cakes, biscuits, etc. So there's quite a few things that need to be done in terms of activities, tasks, and so on in this central box. What about how do you know when if the tea is okay? What would be the controls?
The color of the water after the dilution process.
Yes, let's say the brewing condition, maybe. Would you tie that to maybe time?
Yes.
Yeah, time. Would you tie it also to the amount of tea versus the water?
Yes, definitely.
The controls, somebody would probably taste the tea as well. So in the case of the tea lady that we saw previously, she would taste the tea. If you're going to boil something or you're going to warm something, you're going to probably measure the temperature of the water before you decide that the water is ready to be poured on the tea or in the teapot. So the controls here are actually quite easy to pinpoint. What about the enablers though? What do we need in order for us? So what are the enabling things? And we can call these also enabling systems.
First of all, we need the tea.
Yeah, we need the tea, yeah. Now, we mentioned that this is a good example also as well, where before when we were speaking about the inputs, we did actually mention the type of tea. But we separated the fact that we were asking the type of tea from the fact that we needed the tea. So here what we've just decided is that the tea is considered as being an enabler. But it could also be in the inputs, by the way, depending on the scope of the actual IPO diagram and the process map that we have. So I think you'll agree with me that we need a teapot, we need a kettle, we need the teaspoons maybe. We need maybe a timer or timing device. We need to have the right tea because that will enable us to make the best cup of tea, the expected outcome as well. And we need to have enough tea, we need to have enough sugar, milk and lemon. So when we come to looking at our little process, we should have started off also by asking ourselves the basic question or a couple of basic questions like, is the tea for me? Is it for a family member? Is it for a friend? Is it for a visitor? Is it for somebody I don't know? So for example, if you have a Japanese visitor, the Japanese visitor will have a completely different approach to making tea with respect to somebody coming from the UK or maybe Italy, etc. So we need to bear these things in mind. Just to give you an example, this is what I put together. Well, actually not me, but also another in another training session. So this is an example of the IPO diagram completed for tea making. So if we're going to improve a process or even just understand the process, we need first to map what it is and how you currently do it. You need a tool to do it, for example, the IPO diagram. You might want to consider also the process or the processes that are tied to this specific process. For example, if you're going to invite somebody for tea, you might want to consider the preparation of the cakes, the desserts, and so on. And ask yourself if the process is always the same or you tailor for specific reasons. So if I go back to this particular slide, this one here, then these things here, this process, although fundamentally the same, could change depending on each one of these elements here. And we could quite easily replace the idea of making tea with the idea of making coffee. Now, I've been in Italy now for a long time, so maybe my way of looking at coffee is probably very different with respect to when I arrived here many years ago. But for me, coffee that I drink is using the mocha. That for me is the way you make coffee. That's me though. That's David that's saying this. But if somebody has an automatic machine, like I don't know, the one by Nescafe, not Nescafe, Nestle, then it might be an automated machine. Now I'm as a user, I prefer the old way of doing it, meaning the mocha. Why? Because for me, it's a process. It's not a process, it's a ceremony. While for other people, it's a process. So in this mapping of my particular way of making coffee with an IPO, it's actually a ceremony. So there's a lot of rituals going on in my walkthrough of this process of making coffee. How many of you make coffee like me using the mocha, or do you use an automated machine?
Definitely a mocha.
I couldn't do without that process now. Well, process, my little ceremony. establishing how much coffee goes in, how much you compact the coffee, how much water you put in. So quite a few things. Yeah. So we've got another 15 minutes. So what I would like to do is to dedicate these last 15 minutes to a general discussion and ask you for some feedback about the previous lesson and this lesson. What were the things that you enjoyed, that you thought were very useful, and what are the things that you would like to see maybe in the future? And in general, your thoughts about systems engineering.
If I may,
Yeah.
I would say that I don't want to be in Italian. I would say non voglio sembrare ruffiano, but I enjoyed until now all the lectures. I think they were clear, and the examples, they might sound trivial,
Yeah.
but they actually helped me, as I said before, to actually understand what was going on, and made me understand that I actually did not understand that profoundly in the first place. And this, if maybe there is one critic, is that to talk about standards is always hard, because they are fundamental. Yeah. But at the same time, they are quite aleatory and to the general audience boring. Yeah. And so it maybe I would say that less time could be dedicated to standards, and just to have people understand and know that they exist and they are important, and explain why they are important. But maybe less time to standards will make available more time to make other things clearer. Maybe this is my opinion.
Okay, good. Sorry, I'm missing my laptop, but for some reason the power socket has gone off. Wait a minute. Allow me to move to another, because I might lose the connection. Hang on. Is it charging? No. Sorry, I just need to move to another room because the electricity has gone off. Can you still see me?
Yes, David.
Yeah, I've moved quickly to another room before I lose the power. Yeah, it's back on. Just a second. Can you see me?
Yes, David.
Thank you. Sorry for the inconvenience, but the electricity supply went off, so I had to move elsewhere. So standards, yes, I think maybe we could have shortened it a bit. That was a very, very short version. If we would look in the standards, I know these are particularly difficult to appreciate, but if we'd applied one of the standards, you would have seen the advantage of, for example, the system architecture standard is a good example. But point taken.
For example, I agree with my colleague about the standards. For example, could be interesting maybe introduce a kind of workshop to, for example, try to develop a small project and trying to follow each of the steps by the standard, and maybe by the also Yes, the diagram, the flow diagram to develop, for example, a product or something else could be something maybe interesting in future. But for me, the system engineering approach, it's very interesting, new, and I think that there is a lot to deal with it. And for example, maybe I would like to learn more about it and also make do the test to take the certification and also try to learn more skill about it, because it seems that in the industrial world it's very requested kind of
No, it's very true that there's a strong interest now in systems engineering in the industry. Why? Because they've realized that each one of the usual engineering disciplines find it very difficult to have a systemic way of looking at the product or the service, or maybe product and service, which is typically the area of expertise for the system engineer. But it's certainly true that both the certification and also the application of systems engineering will certainly help you to appreciate and apply systems engineering on a daily basis.
Yes, just 2 notes about one is about standards, and don't forget that always often standards are related also to regulations and rules that must be satisfied by a product or a service. And think about the Formula One, which is a typical, very challenging domain. If you read the rules and the regulations, most of them, in practice, they will design the car for you. So you have several constraints coming from rules and regulation that represent a sort of system requirements that you must achieve or meet. If your product is not compliant with these regulations or rules or standards, you cannot sell. In the case of Formula One, you cannot race with your product. So take into account that in most of the domains, and David knows very well, because Flex, the previous company in which David was employed, worked on and works on machine in the medical domain, which is regulated, maybe over-regulated. And so when you have to be, and this is a problem for young engineers. In my experience, most of them ignore rules, regulations, and standards in the sense of constraints on the design of a system, of a product. So you can think and you can design the best building, the best tower, the best bridge, the best machine, the best aircraft, civil or military, the best network, the best whatever, but if this product or service is not compliant with rules and regulations at the levels that David talked about, national, international, and also maybe in our case, European, you cannot sell and use your product or service. So please pay attention not only to functional requirements or user needs, but stakeholder requirements, stakeholder needs, where a stakeholder is the authority that will qualify, will authorize to sell your product or service. Okay, this is very important. And think to Formula One. If you take the rules, regulations, and standard, in practice, you have the car almost designed. And if you remember Adrian Newey, who is one of the best engineers in Formula One, he always says that we don't have space for creating something new because the rules design the car. So there is very little space for an engineer where to innovate, where to achieve performances and higher performances and so on. So standards in the profession, but also standards in the product and in the service. Don't forget rules, don't forget regulations, because if you want to sell product or service, there will be some authority that will qualify, will authorize, will approve what you are going to sell and to deliver to the market, okay? I don't know if David would like to add something. I know that you have a lot of experience in this.
Yeah, I think that people are sometimes very surprised. You know, I mentioned that thing about the tailoring of processes. And I don't know how many times I've said this, but the vast majority of companies, but also people, their organizations, etc., in some way tailor something to suit the circumstance. So whether we like it or not, whether it's the best approach, whether it's the optimum approach, we are always changing something in our processes. The issue for me is that it's never documented, or it's very rarely documented. And the other issue is that if it is documented, it's not documented in the right way that everybody can understand what is being changed and why. That's why we need to have tools like the IPO, but there are obviously many, many other ones that are more sophisticated than the IPO diagram, because otherwise we get lost in the detail. That's the first thing I would add. The second thing is that when it comes to designing a system, people think that the system engineer, or for that matter also the design team, have this super detailed description of what needs to be developed. In reality, it's never like this. Sometimes it's so generic, and I can give you some very good examples of this, where the customer has come to us and has just said one sentence, nothing else. So we're not speaking of a document that has maybe 50 pages of explanation. No, it's usually just a sentence, or maybe just a high-level description of what the idea is. And I can show you a very good example in an industry that you would expect to be super highly detailed. Here is an example. This is in subsea. So in oil and gas, essentially. So they started off with something that is very high level. Can you see my picture?
Yes, maybe.
So it's a very high level picture. So there is something very, very simple with a description and also a collection of concepts that you see here. And they're focused on one concept, which was concept A. This is the actual ops-con diagram and the con-ops diagram combined together, and this was the high-level description of the con-ops for the concept A, and this was the actual this was the description of concept A. This was it, and from this they had to develop the system. So
in some cases you can say that standards, rules and regulations will help you, because you have this statement, but there are a lot of rules that you must respect for building such a system, because you must respect safety rules, international, national, European, and security rules, and about mining oil in the sea, concerning the environmental and so on. So I imagine that you have this statement, which is a user need, but you have a set of other requirements that you can call even constraints, or that will come from standards, from rules, from regulations, and that will affect the design, obviously.
In fact, from this description, I developed this. So, and what I discovered by doing this was that there was a remote vehicle, so a robot essentially. There was the actual spar, so the oil rig, and then there was the support vessel. And all of a sudden, as I was developing the system, I said, is this what you normally, in this particular case to this customer, is this what you normally do? And what the answer was, yes, but not exactly in this structured way. And I said, this is exactly why you need systems engineering, because it gives you a structured approach to developing the system. Now, I'm not saying that this particular customer wasn't aware of this, but you need to, how can I put it, have a mindset that allows you to think systemically before you actually think systematically. And they really appreciated this approach. And I think this is going to be a key expectation. Actually, it already is an expectation from systems engineering as system complexity increases. By the way, just to develop that specific system, which is the one that you see captured here. So this one here, this thing here, this yellow collection of boxes. It's developed through a process like this. Just a second, I've got it somewhere. It's developed through is that there? No. There it is. This is the life cycle management model. Can you imagine the processes underneath this life cycle model? And for the systems engineering part, it's even more complex. So that's I think a fairly good summary of the challenges that we have in front of us in systems engineering. Now, I believe that a lot of the emphasis in the course, or the core of the course, is to translate data into information, and then from information into knowledge, and decide something in the best way. And I think that is also one of the other things that's missing in systems development. How do you define and decide on something, particularly when it comes to choosing a critical component, developing a part, or maybe outsizing something, farming a certain design to a supplier, or maybe other things like decision management.
Okay, David, and obviously systems engineering is a very wide discipline, and in these 4 lessons we will give you just an overview so that you can maybe acquire more knowledge and skills in additional courses that are provided also by our partners, by SOSE. If you will become a member, there is a wide library of webinars on the SOSE website. And the other note is about agile systems engineering. So obviously, maybe in some cases you don't have a complex company, or a big company, or a traditional application domain for systems engineering, such as defense or space or automotive, energy, and so on. But we see there is a very lot of interest in lean and agile systems engineering. So there is a working group in ICE, as an example, on agile systems engineering. Why? So that you can apply a distilled version of all these processes, technical processes, and so on, maybe in a medium and a small enterprise, or in a more maybe not so complex application domain, or a product or service. But don't forget that the devil is in the details. So you imagine that your system is simple and your product is simple, but maybe it's not the case, and you need maybe advanced techniques also for dealing with what it looks like a very simple product or project. However, the time is gone, and I just would like to share the plan for tomorrow and the final assessment. So give me just 1 minute, no more.
Oh.
Okay. Okay, I hope that you can see my presentation.
Yes.
Yes.
Okay, so we will end this module tomorrow in the afternoon with a lesson on systems requirements and architectures that will be given by Lucio Tirone. He's the director of the entire EMEA sector. So it's a wide sector of INCOSI, one of the 3 sectors in INCOSI, and the area is Europe, Middle East, and Africa. So Lucio Tirone is our past president and currently is the treasurer of the association. And then he will talk about system requirements and architecture. So we see more details on requirements and on architectures. And the final assessment. Final assessment is scheduled on February the 2nd. So in the afternoon, so same time slot. And we will provide you with some exercises that you will solve in 1 hour or about 1 hour. Maybe you can organize you can work in small groups, 2 or 3 people each group, and then you will have to discuss the solution that the group will propose to us in the same time slot. Okay, so we will have about 3 hours for the final assessment, and you can find some example in the folder that are already available on the team. So you can see some example of the exercises that will be proposed to you. Okay.
Mr. Garro, if it is not possible to attend the final assessment session, is it possible to, I don't know, maybe register the presentation of what, Professor?
Last time I feel it was registered.
No. Yes, I didn't express myself clearly. I was saying that if it is possible for me to present myself resolving the problem and then send it to you for a posteriori.
I understand.
Sorry.
I understand. So you mean if you cannot attend the final assessment? I
will try to, but I'm not sure.
I don't know. However, we will manage this. We will be able to manage this. It will be not a problem. You can maybe send your solution and the presentation related to your solution, and or you can post on the team your solution and the presentation, and we will evaluate. But it's not really. We don't want to evaluate you in an abstract way or just for giving you a vote, but we would like to understand if we were effective in presenting the main topics and concepts behind the systems engineering. So this is the aim of the final assessment. So I think that you will enjoy in solving the exercises. So for my side, it's all. I don't know if David or Agostino would like to close the call.
No, I feel you can do. I was out for another meeting, so please, you or David, feel free.
No, well, I just like to say thank you for being so honest and giving us some the feedback. My request would be this, and this is particularly important for the final assessment. There needs to be much more interaction, not because we want to be glorified in somewhere, but we need to understand your understanding of what we have actually transferred to you. And this is only possible if we have interaction. And what I've seen so far is that the interaction has come from maybe 2 or 3 people rather than the rest of the group. So certainly this is going to be my expectation for the final assessment. I need to see you tackling the issues that we will put in terms of exercises, so we understand just how much we've been able to transfer to you and what are your specific needs when it comes to understanding the implementation of systems engineering in real life. Because this is the one thing is to do an academic exercise. Another thing is to translate it and transfer it into a real project. And this is where we need to see you trying to use our knowledge, meaning the knowledge that we've given to you in real cases or real case studies.
For sure. Thank you. Thank you for your presentation and everything. Okay, so see you tomorrow with me and with David on February the 2nd. Okay.
Okay.
Bye bye.
Okay.
Thank you. Bye.
Bye.
Thank you.
Bye.
See you tomorrow.